Hi, Science 8. Well done on getting the assignment. And so, what I want to do today is go over the answers to this. So, I basically had you kind of research a lot of this on your own. So, this is uh, basically looking at uh, chemistry where we focus in on the structure of the atom and sort of how it's arranged. So let's go through the questions here. So number one, picture of the atom labeling the following parts. Okay, so what you can think of the atom as is basically a sphere. Okay, so it's sort of like a sphere, and at the core it is what we call the nucleus. Okay, so this would be the nucleus. Now the nucleus is basically where all the mass is concentrated. So and in relative to the rest of the volume, this nucleus is quite tiny. So for example, if you were to take the school as an atom, the nucleus would be like a closet in a classroom. Like it'd be really really tiny, yet it would have all the mass in it. Within the nucleus, you have what's called protons, so I'll just call that P, and neutrons N. Okay, so protons and neutrons occupy the nucleus. And again, this is where all the mass is coming from. And then the electrons are in these orbits, just like planets orbit the sun. That's where your electrons are going to be, and you have several different orbits. Okay, so in terms of an atom, the atom definition, it's the smallest part of an element. So for example, if we're talking about copper copper metal is made up of copper atoms. Okay, so it's the smallest part of an atom that smallest part of an element that cannot be that's you can think of it as sort of the building block for the whole element. Okay, and it can't be in normal means it cannot be broken down into anything smaller. Okay, there is a way to split atoms, and that's the nucleus when you're talking in terms of nuclear reactions, but under normal chemical means you can't you can't do that. Um, the law of conservation of mass, that basically says that the when you have a chemical reaction, what you have is your starting materials are called reactants, and your final materials are called products. Okay, so your starting materials are reactants. This arrow is used in chemical reaction and it signifies yields. Okay, so the reaction between the reactants yields your end materials, which are called your products. Okay, so for example, a reaction that we kind of looked at in the biology unit was where we had cellular respiration, right? So we had glucose plus oxygen gas. Okay, so these would be your reactants, and this produced dioxide, carbon dioxide gas, plus water, and then plus energy. Energy is not a material, but this was the byproduct of that reaction. So glucose and oxygen gas are your reactants. Your products are carbon dioxide gas and water. So what the law of conservation of mass is saying, under a chemical reaction, the mass of all the starting materials or mass of the reactants is equal to the mass of the products. Okay, and so in a closed container, and the reason why you see that definition involving the closed container is because the gas can escape otherwise, right? So if you don't let any of the materials escape, the mass is going to stay constant. So that's what we mean by the law of conservation of mass. Okay, some definitions here. So electrons, so these are the things that are outside of the nucleus. They have a negative charge. Okay, so electrons have a negative charge, so that's why sometimes you see them with a little negative sign on top of them. Okay, so they have a negative charge. These electrons are what are involved in normal chemical reactions. So when you have a chemical reaction, either one thing is giving another thing like electrons, so we say that's an electron transfer, or you have what is referred to as electron sharing. Okay, so this describes the different types of chemical reactions you have. The definition of the nucleus, again, the nucleus is the core of the atom. So think of the Earth's core, right? So it's in the middle there, but again, it's really, really tiny, and the nucleus contains the mass of the atom. Okay, the electrons themselves do have a mass, but it's negligible in comparison to what the nucleus is. So it's very tiny, but relative to the nucleus, you can almost think of the electron as having no mass. Protons and neutrons. So protons have a positive charge. Okay, so that's why you sometimes see a plus beside them. So these have a positive charge. Electrons have a negative charge. And so that's one of the things that binds the electrons in specific orbits around the nucleus, is because you have these opposite charges, and one of the laws of electrostatics is that opposite charges attract one another. So it's a way, it's a means of holding these electrons in this orbit. Just like you would have planets orbiting the sun, that's due to a gravitational force. Right here, we call this an electrostatic force, because you have that opposite charge there. A neutron has no charge, so that's what neutron, what we mean to say is neutral, right? Zero charge. So you can think of that as just having a zero charge on it. So the neutron, what it basically does then is it provides the atom with the mass. Okay, so again, the mass is given by the sum of all the protons and the neutrons that are contained within this nucleus. Okay. And so you've heard me use the word orbit to talk about how electrons are arranged in an atom. So what you have in these orbits, these are set orbits, so they're not kind of all over the place. There's defined orbits or energy levels. Sometimes they're referred to as that. So for example, if we look at the first three orbits, okay, so again, this is around, here's your nucleus. Okay, so this would be your first orbit. Okay, this would be your second, and this would be your third. So the way it works is the maximum electrons that can be in the first orbit is going to be 2. Okay, so there's 2 electrons there. Okay, and then the next 2 are going to have 8 electrons and 8 electrons. Okay, so the way it works is depending on how many electrons an atom has. So say an atom has 5 electrons, then what happens is you fill up starting with the first with the maximum of 2, and then the other 3 would be in the second. Okay, and that would be it, and the third would be completely empty, and it goes beyond this as well. It gets more complicated than this, but this is a kind of a good way to introduce the idea of orbits to you and talk about how we basically fill these pockets in space. Because another thing I should mention here with the atom is it's like the way I've drawn it out here, it looks flat, but it's like a basketball. Okay, so it's 3-dimensional. Okay, so it's not like a pancake. Okay, so you've got 288. That's sort of what we try to remember, and that's how we talk about electrons filling orbits. So again, if we had 15 electrons, you'd have 2, 8, and then you'd have 5 in the third orbit. Okay, and again, like I said, this is sort of a simplistic way to look at it, but it's a good kind of introduction. Sometimes what they'll talk about is electrons are arranged like rungs on a ladder. So what they basically mean by that, rungs is sort of where you would stick your hands and feet if you're climbing a ladder. So the same idea, those can be thought of as orbits or energy levels. Okay, and so you have your first level, and then keep going from there. Okay. So I'd like you to be able to know how an atom is arranged. Okay, so in terms of inside the nucleus, outside the nucleus, um, recognize these definitions and be able to talk about how electrons are arranged in these set orbits around the nucleus. Again, think of how planets orbit the sun. Okay, so the next part of this I'm going to have you look at in assignment 2 is for us to even get smaller than what we're looking at here, and that's kind of a new phenomenon, um, which is sort of recent history been discovered, and that's looking at even smaller particles, which we call quarks, these elementary particles. Okay, so same thing. I'll have you kind of use technology to research and get those answers, and then what I'll do is I'll go over the answers with you on the next lesson I post. Okay, so I'll post the next lesson on Thursday. Okay, so on this. Okay, so you got a couple days. Let's try to get that completed. Okay, so I'll stop there. So you've heard we are going to be coming back as of June 1st. How that's going to look, I'm not entirely sure yet, but just wanted to mention the lessons and the materials will still be given online as we've been doing. I think what that class time is used for is if you are having any difficulty with some of the work that we have done or are doing, and you kind of need some additional help with that. Okay, so there won't be any different or new instruction given during that time. It'll just be help with existing instruction that's been given online. Okay, so again, online is still the way we're going to be finishing the school year, but that classroom, actual real classroom time is if you require any help with what we're doing online. Okay, and so you can get some extra help that way. So I will be there beginning June 1st. Again, they're going to come out with a schedule, and we'll just follow that schedule. But again, if you're comfortable with what we're doing and you don't really need any help, then there's not really much for you to do there. But if you're struggling with some of the stuff or you have some specific questions that you need one-on-one help with, then definitely you should come on by then. Okay, so again, keep staying safe and send me any questions that you have. Okay, bye now.